Okay, so I would like to welcome everybody to this Industrial IoT today's session. Today, we're going to be discussing data modeling for IIoT, and I've got an amazing panel of experts here. They're going to help us unpack the principles, techniques, and challenges of data modeling for IIoT. So, gentlemen and lady, thank you so much for joining us today. I'll let you introduce yourselves to the audience. Ritisha, you can go first.
Yes. Hi, everyone. Good afternoon and good evening. Yeah, this is Ritisha from Calisito Infotech Private Limited. So I am working as one of the senior consultants of IIoT there. So I take care of like marketing and managing the customers to us. Yes. So I'm very happy to be part of this panel discussion, and thank you, Kudzai, for this wonderful opportunity. And I'm looking forward for this event. Yes.
It's a pleasure to have you. Thank you. So yeah, Aaron, you can introduce yourself.
Yeah, my name is Aaron Semley. So I work at, I'm the CTO at HiByte. I've been in the industry quite a long time now. I come from Kepware, so really familiar with plant floor connectivity. And now at HiByte, we're more on the data modeling side. So it's a very relevant conversation, a lot of questions. I still a lot of questions, but yeah, looking forward to the discussion.
Awesome. Frederic.
Hello, everyone. I'm Frédéric Desbiens, or Fred. I'm the program manager at the Eclipse Foundation for everything that is IoT and edge computing. And essentially, my job is to ensure that people discover our 50 plus open source projects in the space and deploy them in commercial solutions. So glad to be here and looking forward to the conversation.
Awesome. And Klaus.
Yeah, hi. My name is Klaus. I'm the CEO from Ideationware. We're working a lot with OPCWay, MQTT, but more OPCWay, really industrial IoT. We also teach people here with this stuff to get really hands dirty and to work with information models, to learn how information models can help them to develop less code, to work really with information models as a benefit. And that's my job, to find the way how I can teach my knowledge to the people and how they could use this to make really good things. And so I'm really happy to be here, and we'll see what happens then.
Okay, great stuff. All right, so before we dive into today's topic, I just want to thank our sponsors for making this session possible. So the sponsors of this session is HiveMQ, who are providers of an enterprise-grade MQTT broker, and also Opto22, who are manufacturers of industrial controllers for automation and IoT applications. So we're also going to reserve a few minutes at the end of this session to take questions from the audience. So you can post your questions on the chat, and then we'll get to them when the time comes. In the meantime, perhaps you can let us know where you are watching us from, and by posting on the chat below. Okay, so to begin, maybe Aaron, you can help set the foundation for us here by giving us a definition of data modeling, and then perhaps a few examples of data models.
Oh man, yeah, let's get us off on the right foot, right? Yeah, so data models they're really simple, right? It's just a structured definition of an object. So when I think about the old days of how we used to push data around, even how we do it today, it's tags, right? Our data models traditionally in industrial IoT has been tag data. So it's a name and it's a value. That is a data model, right? But it's just really hard to work with when you have 10,000 tags and you're just pushing them up to the cloud, and all you have is this unique name and a value. So really the basis of a data model is to put more context around that, right? So rather than just name values, all separate, it's a structure of data that describes, an injection molding machine at time X, it has this pressure, it's run this many cycles. And the best example of that, if you've seen, is just like a JSON formatted package of the entire data set at a single timestamp. That is the basis of a data model. And because we've been really tag centric for so long in the industrial side, it's new to us. But if you go outside into IT, data models have existed forever, right? It's not a new concept. So yeah.
Oh, okay, yeah, absolutely. Now, to turn it over to you, Klaus, the terms data modeling and information modeling are often used interchangeably. Is there a difference between data modeling and information modeling?
Yeah, so for me, really clear, a yes, because data models are more, as we said, it's more a tag as a key, a value, whatever in this. So we have to bring information onto it. So when the simple situation here is to explain a data model is more when you have to ask somebody else about what it means and what you can get out of this data. That's especially then you work with the data model when you have to ask somebody about this. And when you have a really good information model, then you get all your information the most out of your model. You can explore it with services like OPCWay has it with browsing or crawling the information model that a tag could give some information about itself, what data type it is, or in what object it lives, or so with references. What means really you can bring information by dynamically generated out of the data into your software, for example. And that's the most point for me in the difference. When you have just data, you have to make information every time. But when you go to a really good information model, you get the information immediately. You have metadata inside, so that you really have not everything to give the same information again, or to build the same information again, just to use it. Okay. Instead of creating or generating the same every time.
All right. Okay, now, Frederick, from the definition that has been given by Aaron there, so clearly data modeling is something that can be done like at any level of the stack. Now, at what level of the stack should an IoT model be created as far as you're concerned, and why?
Hey, gosh, that's a very good question. I think an interesting point of reference there would be the kind of discussion they had at the Industrial Internet Consortium a while back. They published a paper about the characteristics of IIoT information models. Essentially, they said that there are 4 layers there that are relevant. The first one, the base one, being the serialization layer, where you have this raw JSON and things like that. The level 1, the base layer, where you have the numbers, the arrays, the bits. The level 2, which is the semantic layer, where you have properties, units of measurements, things like that. So that's roughly the level of our famous tags that Aaron was talking about. And then the conceptual layer at the top, which ties everything in meta model, class diagrams, and things like that. And each and every of those levels is highly important to what you're trying to do, right? If you don't pick the right model at any of those layers, you will have a system that ultimately will not deliver the type of data or the type of information that you are looking for. However, I would say that obviously you should strive to go as high in those layers as possible in order to define something that's meaningful, which means you are aiming to think about things really at the conceptual layer, but then being able to have frameworks and tools that will enable you to implement this properly in the other layers so that you have something that's consistent, compatible, open, etc.
Oh, okay. All right, that makes a lot of sense. Now, maybe to follow up on that question, what are the common set of characteristics to which a data model could be reduced?
Wow. Fundamentally, when you think about a data model, you're trying to represent something that exists somewhere, right? It's a physical object, a physical operation, something that you are measuring. So at its core, you're thinking like the famous tags, right? A number, or at least a value of some sort. And then there's a unit of measurement. That's really the core of the core. But there's a bit much more to that, in the sense that when you think about this, in isolation, a tag or just a value like that is not something that has meaning. So I think the other interesting characteristic of a full data model are really the relationships between those various information elements, how they fit together. And here there are various ways to obviously to think about that. But in the OPCWay world, I mean, they spent a lot of time defining expensive models that you can leverage that are very complete and all of that, which has the benefit of authors did the job for you and has the disadvantage that it's not tailored to any specific use case that you may have, right? On the other hand, if you model all of that on your own, you know, in your own little corner of the world, maybe you will have this information model that's really tightly customized to your application, but then nobody else speaks that. So you have lots of time spent trying to integrate with other tools in the market or other organizations and all of that. So ultimately, I think when you think about your data model, it's all about, those relationships that exist between the various data elements that you're thinking about, but the way you represent them as well. And you should strive, obviously, to keep an eye on relevant standards there in order to be interoperable, because you don't want to waste time and money just integrating with the rest of the world, for sure.
Oh, okay. All right. Ritisha, let me bring you in here. What do you think are the universal elements in an IoT information model?
Okay, as Frederick was mentioning, it's all about data, the data that we wanted to have in the information model, right? All data are the basic elements. So the way you represent data in the information model. So you can consider a machine in a floor, so machine floor. So you get all data from each of the machines. So independent vendors, there are independent vendors. So you need data even from the plant floor to your ERP or a warehouse management system. So you need data at each and every point. So that is the major element, and that data is represented in information model as a node. So in node, you have all the necessary information like meta information. You have information about the subsystems of your plant floor, and all data are present in your nodes. So nodes form the basic elements of any information model, and that has subsystem of data and all meta information about all plants, all PLCs, sensors, actuators in your plant floor. Yeah. So that is it.
Okay, interesting. I know you deal a lot with the OPCWay, and their approach to solving these information modeling challenges is using what are called companion specifications.
Correct.
Could you give us, maybe for the benefit of the audience, could you give an introduction, a brief description of exactly how companion specifications work and what are the benefits?
Sure. So companion specifications are like standard information models. So you have default information models available in terms of like OPC Classic, from OPC Classic to OPCWay. So there were like built-in data types or built-in information models. Those were like OPC DA, HA, alarms and conditions. So there were many built-in information models on top of which OPCWay companion specifications was built. So OPCWay companion specifications help us to prepare a new standardized model wherein your legacy protocols in the plant floor are also like coming to the standardized way. So yes, and OPCWay companion specification enables you that is the starting point of any information modeling that you do. So be it a Profibus, be it a Modbus device, be it like Allen battery device or any device from the plant floor, you wanted them to be interoperable. So one of the major thing that OPCWay communication specification serves us is the interoperability. So thereby communication specifications will help us to define the way how we represent data in the information model. So OPCWay companion specification has been developed for many industries now, like oil and gas, robotic industry, pharmaceutical industry, and machine building industries. And we see there are still many more industries who need OPCWay companion specification for their interoperability challenges. Yes.
Okay, that's interesting. Now, Aaron, your company is built on the premise that a dedicated layer for data modeling is required in the industry if we are to solve this data modeling challenge. Now, precisely why do we need a dedicated layer for data modeling?
Well, the most direct answer is it doesn't exist, right? If you look today at where we have come in manufacturing with all these like tag-based systems, if we could do everything over, we would rip out all the equipment, we would put REST interfaces on them, you'd query them for data and return this rich JSON payload that had all the data you want, and it would be, we would have remove 80% of the problems that we have, but that's not it. We can't rip and replace in our world, right? So we have legacy SCADA systems and machines that are producing this tag data. We're trying to interface that into the cloud. We have the cloud, the IT folks that are like, well, I don't want tag data. I need contextualized rich data, stuff that I could put in a database, right? Databases have data models. That's the schema of the database. It's just part of IT. But when you go to the factory floor, historically, we've lost that. So you need this kind of dedicated translation layer to say, okay, I'm going to take this, all this mixed data we have on the factory floor, some of which is coming from OPC, some of which is coming from SQL, some of which is coming from file-based formats. Like, we need to bring this together, put it in a common model, which could be, when we're talking about data models, it could be something as easy as OEE, right? Like, this is my standard OEE data model that every piece of equipment, although they're all different, it needs to produce this to be able to play in the OEE ecosystem. And having that dedicated layer that you can define those models, enforce them, and then giving the operations folks the tools to wire data into those really seamlessly. We firmly believe there's a need in the space to kind of integrate the two worlds, and data modeling and a tool to do it is one of the key parts.
Oh, okay, that's interesting. Now, Frederick, one of the interesting projects under your portfolio at the Eclipse Foundation is the MQTT SpaPlug specification, which seeks to address the issue of interoperability in industrial IoT. Now, also for the benefit of the audience, maybe could you first describe how MQTT SpaPlug works, and then maybe highlight what makes it best suited for defining data models that are centered around the operations technology?
Absolutely. So essentially, the story about SpaPlug is this. MQTT is prevalent in the IoT world right now as the leading IoT-specific protocol that you can find in the field. It's well suited to environments where you have bandwidth constraints and things like that, and even more with the future MQTT SN, which is currently standardized at the OSS consortium. The great thing about MQTT is that it doesn't say in the MQTT specification anything about the payloads of the messages. So it's very flexible. The bad thing about MQTT is that it doesn't say anything about the payloads in the specification. So out of the box, even if you have devices and software stack that speak MQTT, they won't interoperate, because essentially the data formats can be anything, and the information, when you use MQTT, you publish to something called the topic, and those topics can be hierarchical. So you have a topic under one and that kind of stuff. And the problem is there's no standard there either. You can give any name to the topics, and then once again, where do I subscribe to this information that I want to get? There's no way to know in advance. So the whole point of the SpaPlug specification is to try to make out-of-the-box MQTT infrastructure interoperable. And the way it achieves this is through essentially two things. First, a standard set of payloads. Second, a standard set of topic structures. But, and that's the key, the payloads in the SpaPlug spec are standard in the sense that they are generic, and you can use them to implement any type of data model, including, for example, the great work that was done at the University of Sheffield, their Advanced Manufacturing Research Center. They literally took some of the OPCWay companion specs and implemented that in their Factory Plus framework as SpaPlug payloads. Because the standard payloads in SpaPlug are so generic, you can express any type of model through them, and you can even define your own SpaPlug payload templates, so your own extensions to the standard model if you need to model something that's very complicated or complex or specific to your industry. So we felt that with that, we had the right balance of standardization to promote interoperability and flexibility in order to be able to leverage whatever data model makes sense for a specific set of applications.
Oh, okay, awesome. Now, turning to you, Klaus. So clearly, we do have like multiple initiatives that seek to solve the problem of data modeling, but to a certain extent, I think that creates a fragmentation or maybe new silos, as it were. What do you see as the biggest challenge to integrating subsystems that use different information models? And what do you see as being the solution to that?
For me, it's the most thing is to bring information to this way that not only technical or really nerds or information working people can use them, that we really can activate again the electricians or technical personnel or employees in the companies, because they have a lot of more experience with the practice in using these informations, and especially they have the better way to interpret data and to give information about what it means, and to bring all this information into information models with using the different kinds of thinking, because that's what companion specifications are. This is really a bubble of people. They have its own language, a domain language in this kind, yeah. And you have to bring in all these information so that at the end, somebody else which has no idea about this can understand it in an information model. You know? Especially when we think about technical solutions like artificial intelligence or something like this, or machine learning. That's also, you need this metadata. You have to understand what it is, and it has to be more communication like humans do. So we have on the one side the machine communication, where we have also like automation ML or different languages which are really concentrating on what will the machine express in information. And on the other side, like ISA 95, we have more what humans expect. So these structural thinking, hierarchies, pyramids of whatever, so that we really have layers, and so it's how humans think. And the big challenges here are really to find a solution in the information model that all these different people can get a look on this and understand it. But not only human, also machines or programs, processes should be able to use this information at the end. And that's the really big challenge here. But I think when somebody, when you get some experts from different domains and you bring them together and they are talking about this, and that's what mostly happens in like SpaPlug, or I think also that there are a lot of people from different domains talking together with these information models, and then they bring their expertise into this, and that makes it more easy over time. And that is also a point for me, that a really good community-driven information model is enveloping over time, the whole time, because it's also language in human thinking. You know? We develop our languages each day. The next generation will talk a very different language as we do. And also I think it will work in the information models at the end. So we will change it, we will talk about this, we will say, hey, I don't understand this, what does it mean? We improve it, and then the next time, different people from different, what we have today, companions, will understand it. So my thinking of the future is really that all this work, what the OPCWay Foundation or OPC Foundation does today, is the very beginning of starting to understand different domains and to start really integration of what do we mean at the end. Because when you see oil and gas or manufacturing or feed mills or so, it's every time the same what they mean, but they have a different yeah, different verbs, different terms, whatever for this, what they do or what they expect. But about these information models, what we have today in Industry 4.0 or in IoT, it has to start, and it can start to talk about, hey, what does it mean? How can we improve to understand it? How can we make it to humans understandable? How can we make it at the same side machine readable, usable? And yeah, a bit much with a lot of text, but at the end, that's really the challenge, what we started with OPCWay, with SpaPlug and all these things. And as you see also, it's great to have these technologies to integrate with each other, because when I'm more a guy which uses a companion specification from OPCWay, now I also can use MQTT to bring it into, and somebody else can translate it to SpaPlug. And that's especially as we work in human world or thinking with languages. And that's especially the best case here, that we start to interact, to communicate, and also to share our knowledge and information without borders in the systems. And that makes it really integrated and also really IoT for me, because an Internet of Things is like the real Internet at the end. Different languages, different people, but at the end it brings for all yeah, some generalization, so that each other can understand the other side.
Okay. All right. Now, well, Klaus, one of the data modeling frameworks that I think is not getting the attention that it deserves is the asset administration shell. And I know you've done some work around that. Could you please give us a description of the asset administration shell and how that it integrates with other data modeling technologies?
Maybe we can have a share for a screen for this, because I think that's really easy, or more easy to.
Oh yeah, sure. You can go ahead.
Try to show this one here. Hopefully you can see this now.
Yes.
See my screen now? Okay. Then because the administration shell is really, as it says, it's a shell to administrate an asset. And the interesting thing here is not just intelligent, because we talk a lot about sensors, devices, PLCs, whatever. It's also about non-intelligent devices or things. And that includes really all what we have in a factory to digital, make the digitalization of it. And in my master thesis, I worked on ISAE 95, so-called micro operation managements, so that we really can say we make a shell for maybe a machine or for a thing, whatever it is, and you can give information in a digital way to it. And it's not just here, like what we here have for ISAE 95, a definition of something, or which capabilities does it have, or what is the work with what we have to do. And at the end, an administration shell is to give first is the definition of file exchange, so that you can send your digital information about assets, also non-intelligent and intelligent, yeah, digital, so that you could maybe provide all your data about a product, like a cup or something like this, to your customers or to supplier, as a supplier to manufacturers, to go the next step with the product life cycle at the end. Because the administration shell also concentrates on the digital side as a digital twin, what you maybe also heard about, and the real production world, so that we can have development and testing on the digital side, and that we can later bring in these to the production side. And also vice versa, that you get also back the data from what you experienced in the real world in digital ways back to the development, and not just thinking about how can I get my SCADA data, or how can I get my sensors to the cloud, or so. Really also to think about how can I wrap some device like a printer, so that it gets really easy. And if I had to change 10 years later the device, I don't have to change my digital representation maybe of it, because I maybe have some more generalized interfaces to it. That's the second step. First was file. I can exchange files about digital things. The second is API, so that we really could communicate or interact in the same way with different things, maybe with new versions of hardware, but we could plug out the old one and plug in the new one. And the third way is really the network administration shell, where really these things can interact with. And there's an Industry 4.0 language designed here in Germany. The Professor Christian Dietrich is one of these guys here in Germany, which is working on this with his group. And that makes it more interesting because administration shells can really communicate in a machine way with each other and thinking of, hey, can you do something for me? Yes, I can. Okay, how expensive is it? And do we have some other in the network we can do this? Do you have time? And then services could calculate in network administration shells later what is the best way to manufacture in an industrial IoT, where to send my raw material maybe to get it manufactured to something else, and how can I get it back in the easy way? When I think about all these things, you need something to wrap the real world to digital encapsulations, so that you really have these. And the good way here, we have automation ML in it at the moment. We have also the possibilities what I discover for ISA 95 B2MML. So I think that really a lot of things from B2MML are able to use it, because at the end the administration shell is just a new representation to get the next level from what we have now, a lot of companion specs and things. And how can we do this now in a real data exchanging world, so that you can make provisioning of things, so that you don't have to change your software the most. So maybe you just have to change a parameter in the administration shell of your device, that you can say, hey, okay, you did 100 pages to print today. That's what you paid for me 1 month, and it's off. But I need more. Then you can change it in a digital way. Also updates, firmware updates, manual updates, all these stuff. And all the changes from the real world could be done in these shells. And that means we have a real interactive and living life cycle about non-intelligent and intelligent things in the Internet of Things at the end. It's a lot of information. It's also really a huge topic here, but I hope it's understandable.
So yeah, well now, Ritisha, I mean, we've spoken at length here about information models and data models, but some members of the audience here might be wondering how the actual information modeling workflow looks like, technically. So could you outline that workflow for us as far as the OPCWay information model design is concerned?
Yes, sure. So now that the first step is identify data, identify data that are really required to make decisions out of it. So you have some data from the plan for, and you needed to take some decision based on that data. So identify that kind of information data. I mean, that kind of information, and you'll have to only pick the information that are like you may need it when you need it and where you wanted it. So you identify that kind of data. So that is the first step, and then put all the data and represent in a standard manner, like our OPCWay companion specifications provides us a standard manner on how we represent the data and the information models. So we put that in the information model, and there are also ways to generate information model, people who are experts in writing information models can manually write it, just define defining objects and reference types in the information model. And then there are other UA modeler, which allows you to generate a nodeset2.xml file, which acts as an input to the server application, be it an OPCWay server, Kepler OPCWay server. Some nodeset2.xml file wherein all the data are represented as information model, and you will also be generated with the source code, be it C# or C code, and you'll get that kind of code. And there are also OPCWay model compiler that also allows you to generate a nodeset2.xml file, which is the input file for the OPCWay server application. And then there you also generate .NET OPCWay source code. So these are the ways you can generate your information model, parse the information model into the server application, and then run the server application so that the client server communication initiates. So all your data that you have picked from the factory floor that you wanted to be needed when you need it, so those information is available, and both the client and server are communicating with that particular data.
Oh, okay.
Yeah.
Awesome. Now, well, turning it over to you, Aaron. I've got two questions for you. First of all, what would you say are the factors to consider when choosing a data modeling standard?
Oh, I'll get myself in trouble, I think, with this one. I would say don't hold off doing anything until you pick a standard. Don't wait for the standards, I would say. There's a lot of value in modeling your data coming out of the factory into the cloud, or even inside the factory today, despite there being a lack of standard. I think the standards enabling interoperability is fantastic, right? But you can solve a lot of pain points by just modeling the data today. So one of our takes is, you can start with a standard like ISAE 95 to give you kind of your topic structure in an MQTT address space as an example. But how you model the data underneath there for a particular type of machine, if you can find a standard and pull in a model, that's great. But the standards community is really starting to grow, so don't wait for that. Go develop your own data model. I mean, we're not talking about 100 pages of definition of what this thing is. I mean, it could literally be 4 or 5 attributes for a machine. But if you can model that yourself and push that up in a structured way, if you can start with a standard and adapt it, that's great. But don't wait for the standards. And the other thing I would say is, data modeling. I think in the long term, there's part of it about that's interoperability and just enabling connectivity really quickly. But there's another part of it that's like a competitive advantage, right? That if you model your data in a certain way and feed it into TensorFlow or an AI algorithm, and you're able to derive insight from that drives efficiency of your business, you don't want to be that. I mean, that's not going to be an open standard. That's a competitive advantage, right? So know that you might start with a standard, but you're going to need to tweak it, and your models will adapt as you learn over time. So standards are great, but don't wait. Yeah.
Okay. Yeah, that's quite an interesting take to it. Now, secondly, we have got the ISAE 95, right? So to what extent does ISAE 95 support or enable data modeling for IIoT?
Yeah, where we see it today as a more practical way is just the hierarchy of your organization, sites, machines, cells. So in what that translates to practically in terms of the IoT world we're in today is that MQTT address space and how you delineate the hierarchy in that space to say this is where the data sets. And that's really as far as it goes. I don't think anyone's using it holistically to model, the actual machines and the data coming off of the machines, but they are using it to kind of model that hierarchy in the address space. So when you go in, there's a standard way for you to drill down to a specific machine.
Oh, okay. Interesting. Maybe Ritisha, while we're still on that topic of ISAE 95, what do you see as being the relationship between ISAE 95 and say OPCWay information model?
Sure. So ISAE 95, as we all know, it is it communicates the relationship between level 3 and level 4, that is MES and ERP systems, right? So OPCWay, it complements ISAE 95 because ISAE 95 layer 3 and layer 4, right? The data is loosely coupled, and we have many asynchronous data flowing in level 3 and level 4. wherein we need to concentrate on the other levels like the PLC sensor levels. The OPCWay information model also focuses on level 0, level 1 and level 2, which complements ISAE 95 standards. So I think there are companion specifications for ISAE 95 standard as well. Where OPCWay complements ISAE 95 in the layer 3 and 4 to also level 1 and 2. So that is what OPCWay does. And yeah, like in level 1 and 2, right, the data is tightly coupled. So you cannot access data when the data are tightly coupled. In terms of OPCWay, as it promises interoperability, you need data to be flowing from all the levels. It should flow to all the levels, right? OPCWay complements ISAE 95 is what my answer will be, could say.
Oh, okay, good stuff. Thanks for that. Now, Frederick, let me bring you in here. Now, one of the most important things about IoT is to be able to exchange information across organizations. Now, can cross-organizational information exchange be achieved using SpaPlug data models?
Yes, absolutely. And certainly that's one of the big advantages of SpaPlug, in the sense that you can represent arbitrarily modeled information models like the ones that Aaron was describing inside the set of standard payloads that are essentially the same, whatever SpaPlug implementation you are using. And essentially, the whole point of what we are doing at Eclipse with SpaPlug right now, because SpaPlug existed before as an independent thing that was contributed to the foundation by Cirrus Link Solutions. And essentially what we're trying to do here is really to make the specification document more formal. Although more formal doesn't mean necessarily more complex, because it will be less than 100 pages in the final product. But really we'll have an open source TCK and compatibility program that essentially will create a marketplace of out-of-the-box MQTT compatible products that speak SpaPlug. And leveraging such a thing, whatever you are yourself, let's say a solution provider or an end user of solutions, is highly important. And that's why in the SpaPlug working group, we have not only IT companies or OT specialists like IVMQ and Opto, our sponsors today, that are strategic members of the SpaPlug working group at Eclipse, but we also have at the table big industrials like Chevron that are there to tell us, hey, we want interoperability in our suppliers, and this is how SpaPlug should be designed in order to satisfy our requirements. And we have a growing stable of potential members that are not traditional IT companies. And we are banking on that, because we need this industrial perspective to be represented in order to deliver something that really will make this interoperability between organizations possible.
Oh, okay, awesome. So, well, still on the issue of information exchange. So, well, normally in an analytics platform, you'd be required to have like consistent time series data for you to make, even on machine learning, to make a prediction. Now, since SpaPlug uses a report by exception, whereby we could have gaps in cases where one parameter changes while the other one remains constant. So how does that get solved? Do you require a third party app to normalize the data? To sort of create a consistent time series data?
There are various ways to think about this. But first, let's take a step back and explain a bit what you mean by report by exception for people maybe that are less familiar with that. Yeah. So when we say SpaPlug is report by exception, it's simply that in a SpaPlug-based infrastructure, you just send a new value to be published when there's a change. In other words, if I'm measuring the temperature in my room here, if it's consistently at 23, then the infrastructure, the temperature sensor will just not report anything. And let's say it goes a bit up or a bit down, then we have a change, it will send a new value. Okay, and this is sent obviously to an MQTT broker, because SpaPlug is coupled to MQTT as a transport protocol. So what happens on the other side depends on how you configure your broker and how you design your application or database around this. because some MQTT brokers will always report the last received value as the current one. So maybe if you poll at this specific instant in time, you will get that value even though it's 5 hours hold, for example. And you can configure preemption periods and things like that to ensure that things are clear if there's no new value or something like that. And then on the data side, you could have database-based strategies in order to circumvent the issue as well. Ultimately, I don't see any value of just recording data regularly somewhere if the value doesn't change, which means that, yeah, there may be tweaks needed somewhere in the infrastructure to work around that. But certainly recording 10,000 times the same value with a different timestamp doesn't bring a business value to anyone.
Yeah, absolutely.
It's
Absolutely.
funny, Kutai. So probably like 8 years ago when I was at Kepware, I remember the first like AI company coming to us and being like, you need to send us every update regardless of data change. And for us on the operations side, we were like, that's crazy. Like, why would we ever do that? But on the IT side, to your question, it's totally on point. They're like, no, I can't have gaps in the data. So it's just another example of IT, OT, that divide, right?
Yeah, absolutely. Anyway. Absolutely. And there are strategies, fortunately, to address that. But yes, you're right to say, I have this sensor that reports 1,000 times a second, right? And I want all of those values. Yeah, why? Especially if you're battery operated in the middle of nowhere, you don't want to do that.
Yep.
Oh yeah, absolutely. So maybe Aaron, while we are talking about that issue now, so obviously we've got this IT OT convergence, but clearly OT and IT are still two separate domains, as far as how they differ their data models. Now, what would you say are the key features of an operations technology data model that will make it seamlessly integrate with an IT infrastructure?
Oh yeah, good question. So in our experience, there's a few things, especially when you get to the cloud side. Like I said before, JSON payloads. If you can get your data model in a JSON payload and submit it up via MQTT or REST, like that is really the best way to deal with it on the cloud in Azure and AWS. You can natively write against that, your functions, etc. If you transport it up in any other format today, and this might change, you need to kind of do a decoding, or you need a step that basically translates it to JSON. So I'd say that's one. If you're moving data to the cloud, some other things that practically people get held up on. The one that you just mentioned, right? I can't have gaps in the data, so you need some layer in there that's going to make sure it gets every update regardless of data change. Another thing, like in the topic structure, for example, you might have the machine ID that the data is coming from, and that's in the MQTT topic or in the REST endpoint call. In general, you want to try to put all of that data also in your data model, even if it's duplicate, because it can be difficult in the cloud side to pull off topic pieces or pieces from like the rest. So you want the data to be fully encapsulated as much as you can. Even if it creates some redundancies, it's easier to handle that than to try to fill it in from other sources when it gets to the IT system. A few other things, try to avoid arrays if you can. Arrays are better supported in the cloud now and in those technologies than they used to be, but you can get into trouble. And then try to cut back on your hierarchy, because depending on the storage system that you're putting the data in or the technologies you're feeding it into, if you have a lot of hierarchy, you can run into trouble and you'll have to flatten it. So those are just a few things that we see.
Oh, okay, awesome. Now, Klaus, when it comes to building software, particularly industrial software, what is the significance of an information model?
Microphone back.
Yeah.
Yes.
Yeah, especially the significance of information models for me is really the minimum what you should have is an information model ready state of software in the industrial, like HD ready or so, or today TSN ready. So that means for me, as we heard, that you have some ideas about your hierarchy, how can I collect data to informations and all these stuff, and to build out some tree of it that you can browse through or walk through, and that in the best way with the situation of a definition like SpaPlug has, where you can find in without any questions to other people. And a must-have for me also is to save time. The resources and to get more flexibility is to present metadata inside. So if you have some, as we heard, temperature or something, then I think immediately on average or maximum, minimum, something like this, that's also really significant what information model can bring, so that you have values or types which give you some points where you can say, okay, I have to fill in this in my development. As a developer, or because some technical guy made some progress about this to say, I need this information that it builds in, or data to build an information at the end. And also in thinking about OPCWay and SpaPlug, for me, it's significant that you can morph or change information models. That means it's not static. It can adopt the situation by events, so that you bring in more data points or tags or building informations. And that's the most significance for me, that an information model at the end can change with the information at the end.
Okay. All right. So maybe again, briefly, Klaus, because I think we're going to need to make some time to take a few questions from the audience there. So now, to truly achieve the seamless interoperability in IIoT, I mean, there's got to be an element of plug and play auto discovery to it. So is plug and play a feature of a data model or information model, or and to what extent is it supported in the current data modeling technologies?
For me, that's really a key at the end, that you can discover what's available for me. That's really the first information when I'm thinking about my environment. What can I use? What is there? What can I have in services and so on? And when I think about SpaPlug and also OPCWay, these are technologies. They have these. You can discover. You know where to look for to get to your deep dive, to get your hands dirty on the informations, and that is really important. And I think that the most technologies what really have information models, they will provide discovering and also a kind of plug and play, because plug and play could also be when we think about HiveMQ and Canary or something, so that you can say, okay, I have a template inside what I just have to do once. But if I have multiple sensors of these template, I don't have to do anything anymore. It just would be found, and then I get it created in my dashboard or so. That's a really good example when I'm really have the situation of an information model, because that means the software finds things, can see what it is, or can make some decisions about the state of the data or the information. And so yes, I think it's in the most used IIoT technologies available that we have discovery and a kind of auto plug and play for me.
Okay, all right. So let me just pick a few questions here from the audience. I've got one from David. So David says, given that Frederick has mentioned that it is possible to express the OPCWay custom specs using SpaPlug, what problems do the rest of the OPCWay specs solve that are not addressed by SpaPlug MQTT? I don't know, anyone wants to take that?
Well, it's a tricky question. Since I'm the culprit of that question, let me have a look, stab at this. Well, first, I must say that the Eclipse Foundation, we completely support both SpaPlug and OPCWay. So we have the Eclipse Milo project, which is a Java-based implementation of OPCWay. And then we have obviously the SpaPlug working group and associated projects there. The thing is if you have to consider things in a historical perspective, right? In the sense that originally OPCWay was not necessarily implementing publish, subscribe, or any of those things. It developed things over time, right? Initially, it was more of a mesh thing, whereas SpaPlug from the very beginning has been involved around MQTT and publish, subscribe, and all of that. So there's a reason for OPCWay to exist. And very good reasons at that. And then on the other side, there are very good reasons for people that wish for a simpler alternative, which was based on MQTT and publish subscribe patterns. And that's how SpaPlug emerged. And I see neither of those conquering the whole market. There's a place for each of those technologies, in my opinion.
Okay, awesome. Now there is another question from Mohammed. He says, how does asset administration shell differ from digital twins?
Differ, was it? I understood right, huh? Differ, but I think more it's a kind of. So digital twin, for my thinking, is the more basic on using administration shells for this, because you can build your own things at the end. But I think especially the digital twin association, what's founded, I mean, this year, it's really young foundation, but for me, that's some kind here in Germany, what works really together. But it's not the difference between, it's more you use administration shells to do the digital twin at the end.
Okay, all right. So we've got another question from Yako. Yako is asking, what is the role of the unified namespace? Maybe Aaron, you want to take that?
Yeah, that's a good one. Unified namespace it's a concept today, right? And then it's implemented today via solutions like high-byte to data model data, and then an MQTT broker that serves the publish subscribe. But I think it's over time it's going to turn into a product, right? The concept. The reason unified namespace is so interesting is because for so long in the factory, we're used to not a unified namespace. We're used to all these segregated systems and these point-to-point connections. And if you want to get access to the data, it's going to cost you a bunch of money and a bunch of time, and it's painful. Unified namespace kind of comes in and says, well, if we can publish all this data in a standard format to a central place and anyone can come in at any time and get access to it, I mean, that's music to my ears, right? That sounds phenomenal. So I think it's still the early days of what the unified namespace is. It's like a block in the architecture, but conceptually it's that idea that we have these nodes that are going to publish standard data into a standard place that everybody can get access. And we're going to remove the need for all these point-to-point integrations that we see today in the factory.
Okay, awesome. Now, Ritisha, I think I still have one more question here for you. So, well, we know OPCWay has a PubSub specification. Now, what I would like to find out is the information model preserved in the when using PubSub with OPCWay?
So there is no yes or no answer for this, because it completely depends on the use case and the way the PubSub model is implemented. So PubSub is loosely coupled in that perspective. The answer will be yes, but it particularly depends on the way we implement the PubSub. Yes, good sir.
Okay, all right. Okay, I think let me see if we've got other questions here. Okay, while we're still looking for a question here, so Frederick, maybe in conclusion, what's your advice as far as choosing a data model is concerned?
Oh gosh, my advice would be to really find a balanced approach, where essentially certainly taking into account the various standards that are available to you and relevant to your industry is important. Whereas, as Aaron was suggesting, there's value and even a competitive advantage in doing some level of customization around there. Over time, you know, the threshold or the right place to be between those two extremes will change a bit, in the sense that I expect, for example, in the AI and machine learning world, that some standards will emerge where you'll be able to download or leverage pre-made models if you know, that would be linked to some of the existing data standards, for example. But at the same time, this will never replace the insight you have about your own operations, your own machines, your own industrial processes, and there is value to that. So to me, key to really pick the right data model is to be aware of what's outside and what's inside your organization, and balance the two in order to reach the right the right balance between customization and standardization. And SpaPlug is a very useful tool to that, because it literally borrows, on both sides of that equation to, we feel, bring forward a valuable approach.
Okay, and then Klaus, I think maybe in 30 seconds, what's your advice as far as picking a data model is concerned?
For me, it's more, I love ISA 95. For me, it's more a framework like .NET is, or something like this, because what you only need is an ID and a description. That's the tiniest thing you need in ISA 95 to model with. And but it also brings a lot of examples into your thinking. And as well, when you take the time to understand ISA 95 a bit more, you will find it everywhere. Also in SpaPlug, I think we will find things at the end, because that's really one framework I found which describes human thinking more as a framework, really, because you can do it your way. You can model as you want with these. And for me, it is really, understanding each other, but having more a framework than concerns or than borders or whatever. Because as Aaron said, at the end I can start with ISA 95 in really tiny steps to make some hierarchy, to make the first data available, to make it human readable, to make it explorable, and all these stuff. And that is more important for me, to have a really good data modeling tool at the end also. Not just the communication or the if I have a broker or a client server. As well, when you think about OPCWay, the question what Frederick got, try to send your SpaPlug output to a PLC programmer, so that when you start your first meeting to bring the plan to work, I think it would not work. But with OPCWay, I can send them my XML output of my server. He can start up with the PLC as a virtual client from my XML export. And if we met the first time, we just plug and play and it starts. And at the end, we will use SpaPlug to go to the cloud maybe and exchange data with some cloud services. As we heard today, a lot depends. It depends on what do I need, what makes the most value for me in the project, and what feels good and what makes progress for the people. That's really more important. And I know that a lot of information models, especially with standardization, at the first time makes it, when should I learn this, or how can I get into this or so. But at the end, I think it's also important to find some mentors for this, people that use this every day. They get maybe 1 or 2 days with you, and then you say, hey, ISA 95 is really easy. Or OPCWay or SpaPlug, whatever. Then because each technology has a mainstream of where it could be useful for.
Okay. All right. Unfortunately, we've run out of time. That was a very insightful discussion. Thank you so much to our panelists for coming on to the show to share their insights. Thank you so much. And also thank you to the audience. So until next time, it's a goodbye.
Thank you, goodbye.
Thank you.
Thank you.
Thank you for the host.
Bye, everyone.
Bye-bye.